Okay, I wasn't really planning on covering this circuit, but you know, it had some interesting results. It's the 723 base switching power supply. Um, and, you know, the theory, and this is out of Hazen's textbook, is basically touched upon here, but this isn't the version I actually built. I'm too afraid to move anything. The circuit's right there, and I got all this shit hooked to it. Um, but you can kind of see, you know, some of the theory there. If you, I'll try to go slow so you can read it yourself if you want to. But yeah, that's all there is on it. But the circuit itself, shit, I guess I'm going to have a hard time showing you with all this crap in the way. The circuit I built is closer to this one. Again, this is out of the data sheet in the back of the book for the 723 regulator. But what I built is a variation of this. You know, again, straight out of their data sheet. I'll probably need to change the focus on this anyway, so shit, I made it worse. It's hard to hold the freaking book and do this at the same time. But yeah, you can kind of see, you know, it's actually supposed to put out a couple of amps and so forth. I don't know if it can do that or not, but you know, I kind of built this thing for the shits and giggles of it. But of course, I hate fixed voltage power supplies, so I attempted to make mine variable, and which I can only say is partially successful. But you can see the you know, the schematic, you know, of what I built, and basically this is, you know, pretty much component for component. I mean, I didn't make any modifications or anything outside of getting rid of all the damn circuit board burrs and solder splashed on the back of the board to get rid of the shorts. Um, but basically, this part of it is exactly like you saw on the data sheet, including the 50 ohm resistor. I used two in parallel to get it down to that limit, so I just left pretty much everything over here exactly like in the data book. But over here, I tried modifying the circuit so I could make the voltage variable. Again, I had no idea what to really expect, you know, because of how this thing operates. It's unconventional. You know, if you read the Hazen book there, you'll see he basically talks about that being kind of unconventional. But, oh, and by the way, here's the circuit board if you're interested. Um, so these are just 0 ohm jumpers. So, um, but I'm not going to go into the theory of it. Like I said, you can read it yourself. I mean, honestly, I hadn't even refreshed my memory on it yet. You know, and this is an unconventional power supply. You probably wouldn't want to build something like this. You know, there are plenty of newer, you know, switch mode power supplies, but it is current limited. You know, it does have, you know, as you can see in the schematic over here, you know, it does have, that's a current limiting system right there, so you could make that adjustable theoretically. Um, you know, and the voltage, you know, certainly is adjustable. So if for some reason you wanted to do this and you happen to have some 723s lying around, you know, you could. But I wanted to, you know, kind of show you what the results are. Right now, I mean, I'm feeding it with 34 volts, and you know, supposedly I can go up to about 40, but it won't change the output because the outputs are, you know, still kind of limited. You know, the maximum voltage on it, you know, it ranges. It, you know, I thought it was going to be between 2 and 15 volts, but it's actually more like 5 and 16. But you know, hey, I didn't know what to expect. Period. Probably could have gotten better range out of it by using different adjustment scheme over here, but anyway, that was the best I can figure. But yeah, I got 34 volts, and right now I actually do have a load hook to it because this thing doesn't actually operate at all apparently without a load. I mean, it'll generate just a voltage, and apparently you can't vary it, but I could be wrong about that because I got like a 25 turn pot or something on that, so I might just not have gone far enough with no load attached to it. Because over most of the range, it doesn't do much. So who knows? But but you can see here in the oscilloscope, you know, and I've got, you know, 100 ohm resistor attached to it as a load, and you know that's our current at that voltage, and you know, which I probably could up the current, I suppose. See what happens. I haven't tried that before. Try turning my potentiometer here up to 20 milliamps. See what the scope's doing up there. Barely. I zoomed in. You know, got up to 30 milliamps at about halfway. But I don't want to turn it because, again, I don't have a heat sink on that thing, and you know, transistors still running pretty cool even without a heat sink right now. But you know, you can see the thing. It was operating at about 19 kilohertz. So, and that's that channel, and I basically just hooked it to the diode there, you know, to get a reference signal to see what kind of frequency it's running at. So it's running about 18, 19 kilohertz right now. And I had to put my scope clear down to the 5 millivolt range, you know, to actually see that signal. So, and you can see, you know, on that channel, that's the noise coming out of it. So it's about 390 millivolts, although some of that certainly is coming from the power supply here. But like I showed in a previous video. But you know, the point is that's the voltage trace in blue, and the yellow is across that diode, so I can see, you know, get a measurement of the frequency and the switching frequency taking place here. But again, yeah, it's like, you know, 18 or 19 kilohertz. But ostensibly, this is a really unconventional way of doing a switch mode power supply. That's what's interesting about it. But again, it only kind of somewhat works, but I guess it works better than I expected, because, you know, I'm sort of surprised it works, period, especially given the adjustments I made on it and the design. But I'll try to, you know, show you, you know, it operating over the voltage range. Let me try to adjust the focus on this. So I'll try to adjust the voltage range and watch the current and the voltage, and you can't really see the noise, but the current will increase as I increase the voltage. I've got to remember which direction to turn it. This is going to be hard to do because there's a lot of turns. Let me try to see if I can use these arms to hold this camera here, so I can do this more efficiently. Okay. Damn it. Stupid thing, better not. Better not move. Okay. Probably turn it in the wrong direction. I have no idea which direction to turn it. Like I said, okay, there we go. Okay, up to 7 volts. You can watch the current there. It's up to 24, 25 milliamps. So, you know, because I got a fixed 100 ohm resistor on it. So, but you can see, I'll tell you, it's still about 390 millivolts noise on the output. And the frequency, you know, has changed. That's 15 kilohertz now, and that's one of the things that's different about this supply is that it'll, you know, the frequency will change. You know, it's not fixed frequency like a lot of switch mode supplies are. And we're up to 65 milliamps at 13 volts, 74 milliamps at 15 volts, and still about 500 millivolts of noise. So, and we're pretty much topped out with a load on it. Okay, so it's about 100 milliamps, you know, that it's drawing based on the current limiting they built into it, which again, I'm sure my circuit is actually screwing with. But let me go ahead and disconnect the load. Okay, and that pumps up to, you know, down to, yeah, up to 16 volts and down to 10 milliamps nominal with no load on it. You can see how chattery it got up there. I mean, with no load on it, it's pretty much like way out of control. It's 160 kilohertz or something like that. So it's just gone through the roof. And like I said, I'm trying to adjust the voltage down now, but you can tell it's not really doing anything. So I mean, you got to put a pretty good size of load on it to actually get it to do anything. If I plop a load on it, okay, now we're down to 12 volts and our frequency is 19 kilohertz again. So, and you kind of see the waveform a little more clearly, although jittery again, because it's still like 10 millivolts or something like that. 11 millivolts is what it's basically saying. But we still got about 300 millivolts output, but it's at 50 milliamps. I'm going to turn it down because there's no heat sink on that transistor. It's not a super high voltage, but get my thermal imager out and look at it, see how hot it's getting. Okay, but now back down to about 6 volts, and its frequency is 18 kilohertz. Got my thermal imager here, so you can see what we got going on here. Hopefully, it's hard to get a good image. Adjusting the stupid focus on the thing. Oh, damn it. Yeah, let's see. So we're doing about 90 degrees, and it's the chip that's actually 90 degrees. Transistor's actually relatively cool right now. So, but yeah, it's that chip that's running hotter than anything. 94 degrees. So, yeah, the transistor's manageable. It's not terribly hot, but I'm sitting here, at 20 milliamps, so to be expected. Let me turn the let me try just turning it. This will be harder on the transistor, turning it up. Turn this resistance down here. We're back up to 60 milliamps at 80 milliamps at 6 volts, as you can see. You can see what the waveform is doing. Frequency. Okay. The chip seems to be running hotter than anything. The transistor still isn't that hot at 100 milliamps, so kind of be expected on a switching power supply. It shouldn't be that hot. Every time I touch it, it changes the waveform. But the fact of the matter is that yeah, it's about 5 kilohertz right now. At this level with this kind of load on it. So, but let me turn the load back down. Oh shit! Turn it the wrong way. Did you hear that thing? It went I did a short circuit on it, so that's what happens when you short circuit it. Because that was practically a dead short. I didn't realize I was doing that. Let me see what the heat is now. Still basically not terrible. Yeah, I just turn it the wrong way. So let's see what happens when I turn it up though further, because I don't know. Yeah, I can start to hear it. I don't know if you can hear that. Yeah, it's about 113 milliamps. You know, the frequency's getting audible, you know, about 14 kilohertz or so. Let's see what the thermal say. Yeah, the transistor's heated up a little bit. It's still pretty cool though. Dare I touch it? Yep, warm. Yeah, warm. But yeah, it's interesting. So it was a worthwhile little circuit to build and kind of check out. So anyway, I just thought you'd find that kind of curious. I know I did. I'm surprised it works as well as it did, given how I just kind of did my best to turn a fixed supply into a variable supply there, and a couple of years ago, first time I tested it. So anyway, that'll probably do it for this. Yeah, hell. That'll probably do it for this video. So, cheers.